This video going to prove a very powerful theorem. If x is congruent to A mod m, and x is also, the same x, is also congruent to B mod n, it has a simultaneous solution if and only if the GCM of m and n divide a minus b. So let us prove this. If you like seeing mathematical proofs, then please subscribe to my channel. Okay, so we're given that x is congruent to a mod m. Well, that implies that x is equal to a plus some multiple of m, and if x is congruent to b mod mn, that implies that x is equal to b plus some multiple of n. Now, I want to make one little change in this. One moment, please. Let x0 be a solution. So, let's invoke the solution. And I want to make one other change. To make my life easier, I want to say minus qm and minus Rn. Now, the GCD of m and n equaling d, that implies that d divides m and d divides n. Not exactly sure how much I'll need from here, but this means that m is, say, Rd and n is or Sd. Okay. Now, if I take these two equations and I subtract them, let's call it 1. So now I can say from 1, 0 is equal to a minus b minus qm plus Rn. Well, the instant you subtract two quantities and you get 0, you should write that the two quantities are equal to one another. To be honest, if it was me and I wasn't, quote, making this video, if this is equal to 0, I would cross that out and put an equal sign there. Subtract two quantities and you get 0. The two quantities are equal. You want to see a proof of that? If x minus y is 0, add y to both sides, x is y. So if x minus y is 0, then yeah, the two quantities are equal. We proved it. Now, what I'm going to do here is, instead of m, I'm going to put Rd plus R times. I think I may have too many R's floating around. Okay, I used an R here, so let me say m is t times d. So it's q times m, where m is t times d, plus R times n, where n is s times d, but I can factor out a d. Okay, so this implies that, if a minus b is a multiple of d, that implies d divides a minus b. That is, if we have a solution, which we do, x sub 0 I claim is the solution, then d must divide a minus b. And that was the forward proof. The reverse proof? Well, let's list what we're given. We are given that X is congruent to A mod N, M. We're given that X is congruent to B mod N. And we're given that D is the GCD of M comma N. And we are assuming, suppose that D divides A minus B. Now I want to show that there's a solution to this system of equations. That's what I want to show. Okay, we have to assume that we have a system of congruent equations before I could claim there's a solution. Just because I wrote down two congruent equations doesn't, or two congruences, that doesn't mean there's a solution. So we suppose that D divides A minus B. But we also know that since D is the GCD of M and M, D divides M, which implies M is UD, and D divides N, which implies that N is V times D. M and N are both multiples of D. Okay, that's important. Okay, so X is congruent to A mod M implies that X is congruent to A mod UD, because UD is M. It says so right here. And X is also congruent to B mod N, because X is equal or congruent to B, not because, but that implies X is congruent to M mod N, where N is VD. Okay, so basically now we have these two congruences, and since D divides UD and D divides VD, we have, I can use this instead of those two mods. We have X is congruent to A mod D, and X is congruent to B mod D. Right, so does this system of equations have a solution? Okay, so let's make it a claim. I claim that there exists a solution, call it x0. Okay, so we have x0 is congruent to A mod D, and x0 is congruent to B mod D. Now, if this is the solution, if and only if, okay, their difference is valid. Their difference is A minus B mod D. But this is only true if D divides A minus B. Oh, don't worry. That's exactly what we were assuming. Suppose D divides A minus B. So that's a given. Well, this here implies this, which implies this. Okay, so this completes this proof. If you like seeing mathematical proofs, then subscribe to my channel. Why? Because that's all we do on this channel. It's a no-brainer. If this is what you're into, mathematical proofs that is, then definitely watch some of my videos, subscribe to my channel, hit the like button, tell your friends and family and classmates about my channel. As always, I hope to see you in the next video, and don't forget, watch and learn.